All right, so welcome everyone to the Adelaide Microsoft IT Pro Community October Meetup. I should progress the slides. Yeah, it actually works.
Yeah.
Quick acknowledgement that we are meeting on the original lands of the Kaurna people, and we pay our respects to their elders past, present, and emerging. Okay, like I said, it's the October Meetup, and we're your host. I'm Andrew Young.
And I'm Shahan.
More benefit for people online. There's our stuff, our contacts. Catch us on LinkedIn.
And you can catch me on LinkedIn as well. On my blog, where I usually write emsroute.com, all about security, identity and access management in Tune, and everything in between. And I'm also Microsoft MVP in security, and working at Special Technology Services as architect for identity and endpoints.
And I've given up on selling myself, so we'll move on.
Yeah.
But thanks to our sponsors, Microsoft for providing the venue and the systems and all that. Systematech for keeping our meetup group happening, and ourselves for our time investments and the occasional refreshments. All right, so what's been happening just the other week, 2 weeks now almost, Shahan and I participated in the City of the Bay. Varying distances, you can tell by the expressions are proportionate to the distance we ran. So, and then yesterday was Mid-Autumn Festival for those that celebrated. So it's essentially Asian Thanksgiving with mooncakes and tea and rabbits. And it is coming up, but November is next month, and I'll be doing it again. It'll be my 14th year. So I'll be growing and moving and all the things to help drive awareness and raise funds for the research and treatment of testicular and prostate cancers, as well as mental health and so on. QR code, must say. Okay, so what's been happening in M365 space? And I'll try not to cover too much because you'll be covering this stuff next week. So,
go for it.
But yes, the next installment in the SharePoint Showcase blog. Catch that for all the latest on SharePoint. There's been a few quality of life updates in Teams, particularly the preventing the screen capture. So if you're on a Teams meeting presenting sensitive information, that gets blacked out if someone tries to take a screen snip.
Like Netflix.
It kind of does that with documents. So if you got like sensitive documents, it grays out the document, but this is like the entire screen that's being shared, which is handy. You can see that there's a new timer at the top there. So yeah, keep you on track with time, because meetings always love to run over.
I didn't even see that.
Yeah, it's on some meetings I've noticed so far. And then the microphone, you can see there's real-time volume detection now, so you can see if it's actually, there's my mic on. Yeah, you can see that moving. Even when you haven't expanded it, you'll see the little microphone icon has the bar on it as well. The Microsoft List mobile app is getting retired next month. So if you've ever used the app, make sure to bookmark the web version or link to your list, because you'll be using your browser app on your devices, mobile devices to access those.
Does it roll in anything?
I don't believe so. The messaging at the stage is use the browser app to access it. It's going away.
Yep.
And then at the same time, Power BI integrations to lists and libraries will be deprecated at the end of the year. So you've got two options. You can export it to Power BI, which is pretty obvious. And the other one is to open up the list from within the Power BI desktop application. Excel turns 40. Depressing when I'm the same age as this application. Yeah. Anyway, moving on. This one cropped up, and I'm kind of rattled by the naming convention. So M365 Premium is a consumer subscription. It is essentially your personal/family plans mixed with Copilot Pro, with a naming convention that's going to confuse people between M365 Business Premium and just premium.
I can see a name change coming soon. In Ignite.
Yeah, maybe. But yeah, it's hard enough with licensing, naming, and going to your providers and saying, I need this, and then they do this. And the other thing is we're getting new icons for our M365 apps, just in case you got too comfortable with the last ones. We get shiny ones that
3D ones now.
Yes.
More 3D, I should say.
Yeah, well, very fluent and ribbon-based. I do like how the Defender icon actually looks like a shield now.
Yeah.
It's kind of a little bit of the Entra thumbprint as well.
Yeah.
Worked into that, so I like that touch. Outlook looks the same, just slightly colored differently. Teams is a weird one because it just
Might give a slug.
enjoying people. Yeah.
I don't know why SharePoint's bubbly.
Bubble up your information. All right, Intune Windows and devices. We got day one support for iOS, iPadOS, and macOS 26. If you've been paying attention, Apple decided to skip a whole bunch of numbers and follow the upcoming year number for the iOS version. So nice to have some support on that from the get-go. Windows 10 under live, that's next week. Prepare for that. Windows 11 is out and all, especially the latest version, page 2, as well as the security baselines. So if you're managing your Windows devices through Intune, you can start looking into those new baselines now. I think they're annual, right? So there was no H1.
No,
It's 24 H2 was the last one.
Yeah.
It's been too long.
Yeah, so there's a slather of new security features, controls, surface area reduction, and all that. So look into that if that's your jam. And Microsoft is collaborating with Enforcer and Nerdio to help the multi-tenant management in our MSP ecosystem. So check out those links. They're providing some, I suppose, cost-effective solutions for you to try out.
It's in cross-tenant, multi-tenant management.
Multi-tenant, so your customers as MSP. So I think that
Enforcer
So
already does some MSP type stuff in the application, so you can just put more tenants into it and just like one pane of glass.
So it's more of an MSP tool rather than a client tool.
Yes.
Yep.
Yeah.
So like not like a client's got 3 or 4 tenancies. See, you could.
Yeah. Like a large organization. Yeah.
Or acquisitions, I was thinking.
Or they'll have a different billing scheme. All right, moving on to entry. You want to
So this is fairly new, still in preview. Now the conditional access policies can be recovered within 30 days, which is good. So that's just one more feature that's popping up now on the left-hand side on the plate. So 30 days during that time when you're restoring that, it will just take effect immediately to the last state that it was in when it got deleted. But you always got the option to do report only when recovering it. So that's a good thing. And also the audit logs would have more categories and statuses for the deleted conditional access policies as well. So if you are looking into that side of things, and that will help Sentinel as well with those audit logging and identifying who deleted and what.
surprised it's taking this long for this to be an added feature.
Yeah.
Delete policy.
Yeah.
Sure? Yep. Go on.
Yeah. There is no graph support yet. I saw the deleted users, groups, and everything, but not for the policies yet. So probably will have soon. Still in review. So
Paste.
Yeah.
Paste though.
Yes.
Yeah, cool. Entra is getting an access review agent. So if you are using Security Copilot as yet another Microsoft first-party agent, and if you're not familiar with access reviews, if you've got Entra ID P2 or Identity Governance as a license add-on, this is around managing what your users' life cycle is like, or rather the access they have to permissions or resources. So if you've got
SharePoint.
Yeah, so like
nice.
M365 groups, SharePoint groups, or
Fantastic.
this kind of does half the work for you because it's checking, hey, does this person still exist? Should they still have access, et cetera, et cetera. There's activity map to see what kind of paths it chooses when you're having that discussion with the agent. And I'm sure there's still the scheduled access reviews that pop up, and there's approvals to go through and ensure, hey, we still need this person in this group and so on. Yeah, it's fairly new, so I'm having looked at it myself, and I don't have access to Security Copilot, so
Is what?
no, it's I suppose I could set it up for Visual Studio subscription, but yeah. What's new in Sentinel? The data lake is now generally available. I mean, we talked about this a couple of months back. It's just throwing all sorts of raw data into a location and letting Sentinel look over it. At the same time, we've got the Sentinel graph, so yeah, more API access, more fun things, and Sentinel MCP. So now all things are coming up Sentinel, and it just means that we can create agents that tap into all the logging and the insights we can get from it, which is wild because you can just ingest so many different types of logs as well. And speaking of agents, yeah, Security Copilot now lets you create your own agents. Yes. It's a very familiar feel. If you play with Copilot Studio or the agent builder, Yold, it's a natural language process. So you talk to Security Copilot and you tell it what you want. So I want an agent that does blah with these things and that. And
I think this reduces the fact that they have to create all the logic gaps every time they want to do something. So the natural language prompt will help us.
So it's similar with like the other side where you've got Power Platform, you have Copilot agents, and then you've got Power Automate. It's hey, let's use more of the agent, less of the automation tools, and then does it just all merge at the end of the day?
All become tools.
Yes. Like you see, it's very similar to the other experience. Give it a name, give it a description, provide instruction, add tools, other agents, and so on. And you can see the YAML code behind the scenes if you like to play with that. So you've got the no code and the low code options here. Test it out. Just quickly go through this because it's just screenshots upon screenshots, but you can see how it's going to behave and the level of accuracy and all that as well. Activity maps. And you obviously have to publish the agents, so it's just, and you can see what plugins are needed. So in this case, Sentinel and Sentinel MCP, the other tools that you have as well. And then you get your own agent store in the security space as well. And I believe this is opened up to the partner ecosystem as well. So there is a security store. You can sell your agent, I guess. And there's a bigger store to play with there. I think at the same time, about 30 new security agents created by partners have been uploaded and approved. So it's coming along.
All the Copilot Studio ones.
Sorry?
All the agents in there as well.
There's be a different store, but yes, there's just so many there, and that was.
I need an afternoon just to go through which ones to go through.
I've updated the Ninja training. There's an extra link at the bottom now for Purview, but if you're really interested in learning about the specific Defender product, jump into those ones. There's a cloud native app protection policy ebook if you're super keen and you've done everything else. And a couple of things that have happened. I believe it should flow to the actual cert name, but it looks like the course behind it, the courseware behind the Azure Fundamentals is being renamed the Introduction to Cloud Infrastructure. I think more so now that Azure is becoming so broad, they have to split up his infrastructure, data AI, and apps, and so on. I believe I just saw an update to the certification poster. We've now got the GitHub specialty certifications added to the poster. I didn't take a screenshot, but take my word for it and check out the link. And I've kept in the links from last time. So all the hands-on agent creation courses you can do and some extra tidbits as well. Did see the Microsoft Learn MCP server can now be leveraged by anyone really. So you can connect your agent straight to that as a source. quick whip around the other user groups and communities in Adelaide. Very delayed animation. All right, what's coming up? So, we're a few days past the first now, but Microsoft Secure happened last week. That's where most of those security announcements took place. We had our second SAIT Connect community lunch. It was at the Cooper's Ale House in the city. There is a bunch of Entra-related webinars starting tomorrow morning, 2 a.m. A nice Australia-friendly time, just around the what Entra Suite is, how to best set it up and so on. There's also a Tech Community Live with Intune, and also a nice time of 12:30 a.m. The Copilot OneDrive event. So it's not just OneDrive event anymore. There's Copilot everywhere. And this will be the third OneDrive event in a row now. Give that a check out. I'll try and catch that one. Workplace Ninja, there's a couple of events, Sydney and Melbourne coming up. Before that, or between that, there's the Secure AI Bootcamp. So again, there's participation badges, but they're all online webinars, so they're geared for different job roles.
Yeah, Australian-friendly times.
These are Australian-friendly times. So between like 9 or 10 to 4, maybe. You have to register for each session individually, so build your own little session plan. There's a Copilot Security Copilot deep dive, and then obviously there's Ignite next month. So we'll have all the latest announcements or re-announcements going on, and December is going to be late November into December. We're going to have all the developer conferences and stuff happening as well. One in Adelaide, DDD, that's 22nd. User group, we've got Mr. Lee coming in. I did not update that naming, but it will be Power Platform and some Dynamics. The release Wave 2 updates, and then hopefully we'll have our registrations open for the joint user group after Ignite. And I've updated the QR code, so anyone's keen on presenting, speaking, or if you want to request certain topics, just use the form. And I'm going to stop talking. Oh, no. I didn't hide these slides. Yes. Just to shamelessly replug, we've got our podcast, the Outback Security, Microsoft Security podcast from us two and Anto. About to hit 100 subscribers on YouTube, I think, and also on Spotify. So happy times. And there's also the Discord server. So if you're keen on joining that, discussing, meeting with other IT folk in Adelaide, SA, be it students and people already in the job. There's advice and mentoring going on in there. But without further ado, I will now hand it over to our guest speaker. Let me turn this around and hopefully
see what's going on.
Click if you like.
So yes, welcome everybody.
I'm going to plug the power in just in case.
I can't see how much you got.
No, it should be enough, but I don't trust.
So I've put together AI at the Edge. This has been 12 months in the works. This presentation, although I was saying it together the last few weeks, where AI doesn't have to belong in the lab data centers, where we are looking on the precipice of AI going to the edge of devising where we're looking at. I mean, I'll cover all of this, of course, but as AI progresses, as compute progresses, as CPUs progress, we're looking at more and more of shifting that compute from the cloud to the edge. So where the internet isn't available, where AI hasn't traditionally been available, it's now moving to it. Bunch of agenda stuff. I mean, I won't spend too much time going over the agenda because we'll actually go through it. But as a quick sort of summary, we'll have a look at AI and how it's being used, or how I've used it, certainly in the Outback where there's been no internet, no processing, and how I've overcome those steps as well. Copy and paste failed. So a little bit about me. That's now 5-time MVP. Speaker user group lead. I head up the Copilot user group and the M365 user group here in Adelaide, and do a whole bunch of opal mining as well. I don't know why that's different. Opal mining. So a whole bunch of photos of me doing what I do, and there I am out in Coober Pedy looking like an idiot. Very much a noob. That was the first time I went out opal mining. So the one in the yellow jacket was, but the one in the Copilot one wasn't. So I'm a bit more confident around the opal fields and that sort of stuff as well. There is a predecessor to this session, and that was done at Microsoft Reactor before it all went skew with, where we actually looked at a whole bunch of stuff on the platform, Opal AI, detecting opal, how it's actually constructed, some of the gains, things like that. So worthwhile checking out. It's on YouTube. It's on the Microsoft Reactor channel. And there's a whole bunch of content online around that. So the basics, some of the terms that I'll be using, I just want to explain before I dive into it, because it does matter. Some of the stuff does matter in terms of where we're going. So Coober Pedy is 900 k's from Adelaide, 600 k's from Port Augusta. The history of Coober Pedy was roughly about, well, we'll go back to 120 million years ago. It was an ocean, somewhere between 30 and 200 meters deep, called the Aeromagna Sea, inland. How was opal formed? We don't know. That's a big mystery at the moment. We know it's got something to do with silica and the spheral size, and how it was deposited and when and where and why is all very much up for debate. So we suspect that it was, I can't even say that. So and this is the problem. So just on this note, how opal was formed. So when I found opalized shells, and that's all well and good. So we know it happened after the ocean. But the only time you find it is when there's a big crack that leads down through the shell bed. So sometime in the future, it cracked and then infilled. That's all well and good, except then you find opal that's through gypsum and opal through that's got no cracks in it and opal that's in verticals and all this sort of stuff. So how it is actually formed, we don't know, and under what conditions, we don't know still. All we know is that we're not finding it today in terms of the actual opalization process has actually stopped. So no one's finding wet or jelly opal or something that you can't sort of just smear. It's all fossilized essentially. There is a difference between the opal. So opal that's got color is called opal, precious opal. Opal that doesn't have color is called potch. Potch is worth nothing. Precious opal is worth the money. There are two types of drills primarily, but I mean, there's a whole bunch. There's a spin-off drill, which is just a big corkscrew. They dig it in the ground, pull it up, spin it off. It's a spin-off drill. And then the Cadwell or Caldwell drill, they call it up there, which is the big bucket that goes down, fills up, then comes up. And a dugout is just an underground house. So those are the sort of main basics of it. I should also mention, was it last week or the week before, some bloke fell down another hole up there. So that I haven't included any of those slides, but the dangers are very real up there. So most holes are somewhere between 20 and 60 meters deep. So if you fall down that, you're probably not coming back up. So to just sort of reiterate, AI doesn't just belong in the labs and data centers. It thrives where the decisions are being made. And we can look at some of those examples as well. Now, in what form does it actually go to that point where the decision is being made? Does it have to be full-blown ChatGPT that's several terabytes in size? No. But can it do the pre-processing, post-processing, some of the inference or inferences around it? Yes. And then we can do post-processing online. There we go. So we want to have that resilience. I mean, we do have that data sovereignty that does play a part these days. Certainly is coming more and more prominent if we want to have software capabilities for AI and all this sort of stuff. And obviously the performance. So as soon as you go 2 feet underground or 2 feet in a trench, you lose signal. And therefore you're pretty much on your own in terms of internet and cell capability. So that's where I've sort of now pushed with this offline capability of what I do as well. we do have the skills overlap of the whole Azure stack, the IoT at the edge, the containers, the networking optimization, the model life cycles. They all come with their various bits and pieces, their pros, their cons, and they all integrate. And we already manage service in harsh conditions. I mean, everyone's well aware of that. We've got service at the bottom of the ocean. We've got service in the desert as well. We've got open air data centers. We've got wet ones. We've got submerged ones. So it's not like we don't have the capabilities to put AI in these conditions as well. It does come with its own set of challenges, mainly, like I said, that internet connectivity. I mean, talking to someone today where not me, but where they are deploying data centers in the battlefield by a truck and by a helicopter. So kind of cool, but we already have a lot of those capabilities. So beyond the data center and why the edge matters. So, I mean, many industries, obviously, I mean, what I've got there is mining, agriculture, defense, and energy, four big ones that generally are not internet connected for their main sites. They're like their HQs are, but once you get, say mining, once you've got like Prominent Hill up and running, happy days, you've got a couple hundred people, you've got infrastructure, you've got everything there. But while you're out there exploring, drilling the test holes, there's nothing. There is literally nothing. Likewise with agriculture down the back of the farm, we're talking a farm size of, several hundred hectares. Defence, I mean, the battlegrounds, all that sort of stuff, testing operations, proving grounds, all of that. And likewise with energy. Where is it, Moonta, or where are Moonta's up the top of the state, I think. Gotten that wrong somewhere. It starts with M. It's where all the oil is. Moomba, that's it. Yeah, again, great internet connectivity up there. I can't even remember the name. So, these are the areas where traditionally the geophysicists have gone out, collected all their data, their samples, their information, their charts, their drill cores, everything, and they bring it back. And then the processing starts. There's sort of like that discovery phase and then the processing phase as well. And Edge AI enables low processing, low latency, autonomy, and resilience, which, I mean, a lot of it, I won't pull it out, but we can now get AIs and edge processors that are big as a USB stick or a pack of cards. So yet again, are they that strong, massive, maintainable AI? No. But can we start to look at some reasoning, some models on that? Yes, we can. And if we can cut down that process or that time from here's my information, here's my processed information, well, then we're going to see that really come and hold that with bear fruit essentially. Because there's a big lead time between, going back to say the mining, as I know it. I mean, you put your core or you drill your cores. I mean, they could be 2-3 kilometers deep. You got to go through there, got to process them. You got to have your geophysicists go out, and there's 2-3 weeks in the field. Where all of a sudden, after 1 or 2 days, I could start to get initial results. That's starting to bring that time for essentially first oil, first gold, first copper, first iron, closer and closer to finding it. So a bit of an overview of the Azure AI. I mean, there's a lot more in Azure AI these days, of course, but I just wanted to keep it sort of focused. The custom vision, which is changing, and we'll get into that. Form recognition. I mean, you think you've got all your geologists, your gas people, your oil people, your gold people, your copper people, you name it. They're all going to have their own different forms and different data, which is both structured and unstructured. Speech is interesting, and I will touch on that as well because it's not something that a lot of people really consider when we're talking about AI. But as sort of the teaser, you've got your dictaphone, and we can then do all of that. As another teaser is we can also then communicate our processes, and then if our process is documented, have the AI documented. But that's not so much in the AI field, in the actual field itself. OpenAI, Gemini, you name the engine. Can we put it into Azure? Yes, we can. The machine learning, and we're going to see this take off a lot more, I think, in the next 12 to 18 months. A lot more tools and resources are going to start to depend on machine learning. So at the moment, we're in the generative AI phase, which is all good, but Gen AI is really good at regurgitation. It's not good at analytics, analyzing, drawing out those insights. I mean, don't get me wrong, we can do it, and it does it well. I mean, I'm not going to lie, I use it, but machine learning is going to be where we see the biggest gains in terms of analyzing core samples, analyzing X-ray and spectra samples and things like that. Training, monitoring, developing, all that's going to play a part with machine learning. Azure OpenAI, I put that in there because it is still the biggest engine being used in Azure AI, OpenAI and Azure AI. But that is starting to change, especially with things like Gemini being deployed, Grok being deployed, Sora now is in Azure AI as well, which I haven't used, but I want to. But I haven't come across a use case where I might well need to use Sora. Part of that I could see is, and I have been sort of talking to people around this, is that visualization aspect. So if we do have like our core samples and we could visualize the deposit, well, we could make a video about it. Okay. Cool. That looks cool in the presentation, but it's not the cool stuff where the actual data is the cool stuff in this scenario. Azure IoT at the edge, and this is where it starts to get into the cool stuff, is where we can actually deploy these services to the edge device. I mean, there's Azure in a box essentially in various flavors that come in a big container, but I can't put that on a bulldozer. It's going to be a little bit difficult. I've got the power and I've got the weight requirements, no problem, but I don't have the space requirements. But things like NUCs and all the new chips like the Ryzen AI and things like that, well, they're starting to be, okay, well, now I don't need three-phase power. Now I don't need a massive cooling system. I could potentially just glue them to my bulldozer. And that's where I see a lot of this edge computing to be, is not something that's this big that requires a shipping container, but something that's that big that I can just plug into my laptop. And all of a sudden now I've got 128 GPU cores or Blackwells or something just running. And is it doing everything that I need it to? No. But is it giving me that first pass, that first cut, those first insights of where do I actually steer my bulldozer? Should I be going over here because the samples are getting lower, or should I be going over here because the samples are getting more dense? Well, obviously over here with more dense, having that IoT, and when I say IoT, it's also a connected IoT. So I have multiple sensors, multiple different types of sensors around. So yes, I have sensors on my bulldozer, but my excavators, my geophysicists, my chemists, all of that providing all different information that pulls in to the big one. That's in the core room on site, which then is feeding off both online, and in this sense, online is just connected to each other rather than online being connected to the internet. And then cog search and RAG. So cognitive services or / search, it is bigger than just search. So computer vision does fall under the cognitive services at the moment, but that will be moving to machine learning. And yeah, the whole data grounding, the RAG, the ingesting, the vector searches, it's a big part of it, but it's not so much a massive part of it if you're out in the field. Because when I'm out there, let's say I'm looking for oil, what am I going to need to be ragged? I'm not going to be doing searches. I could be doing searches for other information out there, and I want that other information to come through. I want that vector database to go, okay, well, I'm at these coordinates, I'm at this depth, what should I be looking for? And it checks all that sort of stuff. That's great. I want that data grounded in my information. But where I'm looking at is providing the data for the RAG. So rather than drawing it from RAG, I'm putting it in RAG. That's sort of, I'm on this side of the fence. And I always forget what is it. What's RAG stand for? Retrieval augmented generation. Yeah. Is it? Yeah, no, you're right. It's a mouthful. I always forget it. I know it's retrieval augmented grounding, but yeah, I mean, it's good. And I mean, RAG in Azure, just on that note, is actually quite good. I mean, it works well. I've had some great success with it. You've got to get your embeddings and your vectors and your indexes set up correctly. And in order to do that, you need more than 3. 3 is the free plan. So you need about 10, and that's $200, $300 a month. So it's still not the cheapest. And I suspect, just on that note, given, I mean, if everyone remembers 12 months ago, Microsoft chucked around, was it $40 or $80 billion to put all these data centers in? Give it another 24, 36 months and we'll start to see those prices drop down because those data centers will be coming online. That's going to be a massive help. So the whole custom vision thing. So there's custom vision, there's computer vision, and now there's asterisks of machine auto ML, automatic machine learning. It is developed by Microsoft. It's got a whole, well, it did have a whole team for it, but they're now on OML. They also developed Phi 3 Vision and a whole other bunch of models. And it was really meant to be a consumer grade product. So this is not something that you're going to need an IT degree to work with or to use. I mean, what I initially started using was customvision.ai, and there's a picture of a hummingbird on there, and they're like, cool, this is just the end users where we can use it. But it is much more than that. It is backed by the Azure Computer Vision service, which is in the Azure AI portal, which can be found at ai.azure.com, and it's also exposed through Foundry as well. You can actually start to expose it through Foundry. You can actually do two types of vision. One is object classification, and one is object labeling. So, hey, here's a picture of a dog, it's a dog. All right, cool. Here's a picture of a dog and a cat, it's going to say it's a dog. Because it can only see one, it's not going to see both. That's where your classification comes in. So it's a dog and here's a cat. So that's, and we can see some samples of that as well. And it does support offline modes. So the general A1 model is about 16 meg, which not too bad, not too bad. It does obviously grow the more data you ingest, the more size of it, but with about 3,000 images, it's about 16 meg. So I was impressed with that. It is very much not as good as the online one, don't get me wrong, but yet again, we're not looking for that sort of comparability between online and offline. We're looking for what we can actually utilize. So the goal so much in this sense is not perfection, it's usability. And yeah, off mode, edge devices. I was trying to get it to run on my laptop, but I've got the Ron Onyx runtime on there. So that's fun. That is a caveat. So my dev box is obviously x64. My Surface is ARM, and it's not running. So I can't demo that, but I can. I mean, and we want to run it online, I can. But yeah, that's something that will have to change over time, is that whole dependency. And that's going to be hard because you've got your GPU, your CPU, and your DirectML, and how, when, why is the best one, especially now we're looking at devices that we just plug in. So this is where things potentially not, but similar to MCP will help, where we can go, okay, what is the actual device we're running? To the software, I don't care. I just want it to work. You know, and this is where if we could just, you know, drag and drop the different libraries or different models in, that's where, yet again, it should be going. But it's just something to be aware of that, yeah, at the moment, offline is very much hardware specific. It's very much, okay, your x64, x86, ARM, or CUDA, or whatever the actual underlying is. So how it all works is obviously we train it, we train the model, we develop our container, we deploy our container, we deploy it via our IoT edge devices or our laptops. In this case, most of these devices, I mean, we can get the sensors, we can get all that information. That's been around for some time. But that AI processing power is still handled on these now USB sticks that are coming out, and the hardcore CPUs. Now, the hardcore CPUs like the Ryzen AI, we're not talking you still need three-phase power for them. They could run on single-phase power. They're a box 5 laptops deep by a laptop wide, so it's not unreasonable to say I could put that on my excavator, I can put that on my drill, I can put that on my bulldozer with relatively ease. Now, the biggest thing is going to be cooling. The cooling aspect of it is going to be the one. And the whole offline and intermittent connectivity. So just because we're not online in terms of on the internet doesn't mean I won't have my own mesh internet or intranet, Ethernet, intranet, intranet set up where I can have all my components. I was thinking SharePoint days back then. The whole Ethernet, extranet, and intranet, and internet. And we want to be able to recover. So yet again, if I am down in a hole, that doesn't mean my Wi-Fi signal is going to get down there. But when I come out of the hole, the Wi-Fi signal should connect, should be able to process, should be able to do what it needs to do when we come back online. And that's the whole syncing sites back to Azure when we are actually online. So yet again, there's 2 onlines. I'm down the hole, my bulldozer is working down there. I come out, it connects to my local hub, say, the HQ at the prominent mine, And then obviously from there, we go up to Azure as well. I know supermarkets are doing something similar to that. I mean, obviously they're not down the hole, but you've got your local processing, and then once all that's been processed, then it pushes up to Azure to process. Now, I think that's more of a cost and a data consumption. They're actually generating several gig/terabytes of data in store before they push it up to Azure. So they don't want to be pushing up, 10 terabytes. They want to be pushing up 10 gig. So it's a very important way of thinking it. You need to have this ability to connect online, offline, sync, and not miss any data. So how is it actually trained in terms of real time? And this is where I'd bring out Opal AI and have a look. But yeah, I've put 3,000 images in there, and that's of Opal. So that's manually tagging. That's actually putting the data together and then training the model on Azure. So that's all well and good online. But then likewise, we've also now got the offline ability to do that. Runs on laptop, camera, no live internet required. Real world footage down the trenches, spin off drill, the UV detection. So Opal does glow under black light. So we've also incorporated that. And once you're offline, you can run it anywhere. And this is where I'm saying, like with Opal mining, I'm often down a hole that's 30 meters deep. There's no phone, no internet connectivity down there, but I can still now be looking for Opal. I mean, yes, traditionally I can look with my eyes, but eyes are only as good as eyes are. And if we're looking for smaller samples, we've got high resolution cameras. We can actually see a lot more, especially if you're moving into IoT where you're actually looking out of the visible spectrum. So now if you're looking at gamma, X, which I wouldn't recommend being down the whole way doing that, but that's yet again where we can go. We don't have to just stick with the visual spectrum. We can breach out of those because often, they are using different spectra to inspect samples, look at different areas of both the Earth, in the tunnel, out the tunnel, down the hole, out the hole. And yeah, you can run it literally anywhere as long as you've got those sensors and that offline processor. So this is what I mean by the different classifications. If this was 2 dogs, it would just pick up 1 dog in the sense that if it was just the image detection rather than the image classification. And this is where you've got to have those images trained for those classifications. So we can see the opal, the potch, the hand, the rock, which is all well and good, but what we want is the opal. Now, it's not 50% opal, it's how confident the AI is that it is opal. So it's 50% confident that part is opal. And you scale it back, obviously, you sort of scale it up to give you those different generations. There we can see a whole bunch of stuff. So we are looking at, why I included this slide is it's not just that we can only be 1 or 2. We can have like hundreds of different boxing around it to actually detect all the different elements as well of it. Not what of any elements, but objects within a single image. So it's just not like we're looking for one. Yet again, black light, under UV light, at night time. It's all just really what's the input of those sensors, of those IoT devices that come through to show that off like that. So that's obviously not opal, but what happens is you actually get into a trap. Now, with the image classification, it does get into a trap that it always expects something that was white to be opal. And with the sun on the pug's butt there, that's detected that as opal. So this is where you really need to balance your images, balance your data out to be able to make sure that computer vision doesn't always assume that, it's white, it's opal. No, it's not. Or it's a human because it's got a face. That's not the case. It's where you do have to really work at it to balance that. And this is where I suppose Azure Custom Vision, I was going to say computer vision then, is recommending that you do have at least 400 images of each tag that you want. So at the moment, I think, I got just over 3,000 images in Opal AI of opal, but I only have 100 of humans. So it is a little bit unbalanced that it may not detect as humans as much as opal because it's not got that balance. Now, that is something that you have to work on. So yet again, how does this apply to data? is, well, I've got all this spectra data in terms of the X-ray spectra. Do I need to have visual spectra and gamma spectra? It depends on how your model's actually constructed. So if you've got a model that's perfect at, say, X-ray data, probably not, but you still want to have that balance as well. You want to have those multiple feed-ins to make sure that what you're looking in the X-ray is there and the visual is in. It's probably not going to be in there, but you get what I'm saying. You know, we just don't want to have that one data source or that one type of data that's balanced. We want to have that balanced stuff. So the GPT models for reasoning as well. So this is where you actually combine your computer vision with your LLMs. So, okay, Mr. Computer Vision, what are you seeing here? Is it what you expect in terms of the generative AI, is the LLM? So this is where we can say, okay, here's the rock layers, what's the rock type? And this is where we go off to the GPT to say, okay, based on our data that's grounded, and that grounding data back to RAG can be your own. So if you're in, say, a mining company, you can actually have that information at hand, or you go off to, say, the SA geology library and stuff as well to pull that in there as well. Oh, look, show architecture. Yeah, cool. Meant to hide that one. But this is where you can actually pull in all these different sort of GPT knowledge sources. And this doesn't have to be, say, GPT. It could be DeepSeek. It could be Minstrel. It could be Grok. It could be all these different GPTs, or LLMs, I should say, to pull it all in together. Yet again, you get all that different spectrum, that analysis. And this is where things like AI orchestration comes into play. So you do want to have an AI that's more geared towards X than Y. And that may be, it's more geared towards the geology side of things rather than, say, the oil side of things. Because if you're looking for gold, you're not looking for oil. I want to make sure that's clear. But you may, yet again, to give a better example on that, I'm looking for gold, but I'm not looking for iron. Because often gold is found with iron. So yet again, it's a great precursor. If you've got lots of iron, you may have some gold, but it's not always guaranteed. You want to sort of balance that out. And then, I mean, another use case here is finding recommended details of next drill sites. So yet again, based on your samples, based on your takings and your tailings and all this sort of stuff, you want to run that through different IoT devices while you're doing it, gathering that information, and then you want to bring all that information back to the GPT that is connected online and actually have a look at it through there. So these are sort of the whole offline versus online as well. And daily operations, I mean, this is where it comes down to that, I suppose, Sora conversation or I don't even know what an image generator is called besides Sora, but that's where you would build up your graphs, your charts based on your data. So yet again, taking that human component out of it, here's my Excel component out of it. Here's, you know, all the plots that were found, but that's all well and good. That is really based on A, your data, and B, your geology track. So if you want to go, okay, here's our several drill points that we've got. Which way is the dike going, or the split going, or the crack going, or how deep is it? This is really open to interpretation of the actual geologist looking at it. Where, okay, well, now we're not looking at a geologist, we're looking at the geologist, so to speak, with GPTs and LLMs. Can we get that information offline? Yes, we can. But can we get a better information online? Yes, we can. Real examples, remote desert mining operations. Yep, we've covered that. I won't dive too deep into that. The dust and glare, that's a real big problem. So for me, the solution was a bed sheet over the laptop. But if you're out there, if you're moving, 100 tons of iron ore, you may actually start to have short circuiting problems because iron ore is conductive. So yet again, how do we overcome those problems with maintaining our cooling solutions is going to be very interesting. And that's where things like passive liquid cooling could come in. Is it viable at the moment? No, but oil cooling is. So you could maybe have submersible oil cooling for your IoT devices, but that's going to be a big problem. Limited power is, I mean, I know it sounds silly. You've got a D10 bulldozer with 500 horsepower, but how much electricity can it actually put out viably for your devices? Is it clean electricity? Is it not going to blow out everything? And the no connectivity issue as well. We solve that by actually having those models process that offline. Deployable, viable local processing caching. The caching is important because do we have to do everything at the edge? No. Can we pre-process some of our pre-processed data? Yes. So before I go out to Prominent Hill or Roxby or somewhere, I can take a look at what data I've already got from known or previous or historical or legacy data sets and pre-process that and consume that in terms of RAG or grounding or AI insights, my Excel charts, my images, things like that, and build up a model for use in the field. We don't have to just go out there, collect the data and bring it back. We can go, okay, what data have we got available? Cool, we'll use that to better improve our IoT devices and our IoT processing. And the outcome, obviously, before that we get into cheaper hardware. What are they? The H100s, H200s. I mean, they're not exactly cheap processing units at the moment. They're sort of this big, where we do want to start to get it onto a laptop. If we get AI onto a laptop, and I don't mean like an NPU or something like that, I mean true actual computational power, the game's going to change. So in terms of where I see the game changing first will be the mobile devices. Everyone's iPhone is going to have an actual processor that can actually do AI work rather than just pretend to. And then we're going to see it in laptops, tablets, all of that sort of lovely stuff. So the outcome, I mean, yes, we can detect opal in situ, but we actually gain all the ability to use all these AI functions, both online and offline, to better increase our value, our detection rates, our grounding, our information, our findings, and then yet again, pull that all back once we're online as well. And we reduce the manual inspection time. We reduce the time from first drilling to first mining, and that is a big cost. I mean, you think of how big, what is it, Prominent Hill is. I mean, that's huge. I mean, it is absolutely huge. I can see the dust from the Stewart Highway where the trucks actually come, like the dust from the trucks is there. And it took how many years to develop to get to that point? Yes, within a year they were drilling, they weren't mining, but it was about 3 to 4 years between first finding it to actually first extraction of the iron ore. So we can cut that in half in terms of our processing, our scans, our data retrieval, our analysis. It all comes down very quick. Places like BHP are going to be pretty happy. And improve safety and coverage. Now, I haven't touched much on the safety aspect, but yet again, we can use AI. I mean, I've got my AI, it looks for holes. So ideally what you would have is if the human was in the vicinity of the hole, ring a bell, ring a buzzer, tell someone, all that sort of stuff. But also what happens if I come across an asbestos deposit? So all of a sudden, hey, whoa, you need to start flagging this. Don't breathe around it. And that's where I see a lot of it going as well, is this safety aspect in terms of mining and at the edge. Well, shouldn't just say mining, but at the edge, because what happens if there are these threats, these problems, or these potential problems, these potential hazards out in the field? Well, we are yet again relying on humans, and humans are pretty good. Don't get me wrong, I'm not trying to downplay the human aspect, but if we can have that knowledge set, in this area there was asbestos, there was these chemicals found. Like, yet again, in the Outback, there are certain areas that were nuked. So yes, they have maps and all this sort of stuff, but what happens if we come across this bit of chunk of metal? Okay, cool, that's fine. But maybe the AI could go, hey, don't touch that. That's 1947 Army Jeep. That's probably been dug up and it's irradiated. Yes, the human can do it, but can the IoT device help you with that? Can your information help with that? Do I need to be connected with it? No. I can have that information ready at my fingertips. Yet again, put a camera on the front of the car and you can go from there. And yeah, the safety just goes up and up with it. So then we move into optimization of it. Once we actually get it working, how do we optimize it? So Docker will play a big role in this, I think, based on what I've seen, what I've known, what I've done. I'm not a big fan or big user of Docker. I tend to stay native in this sense, but being able to deploy all of these different sensors with all these different configurations, I don't need to manually do it. I just push it out with Docker. Hey, Mr. Geologist, can you push the save button? Yep, cool, done. But hey, can you configure this, settings.config and change this XML file? No, that's not going to happen. Um, we've all been there, we've all done it, we've all been on the phone saying, hey, can you change this setting file? And yet again, I mean, that's another use case where AI can help. I mean, used to certainly in the security world, we'll see, what was it? One of the, certainly at the hackathon, they were using AI to go against the essential 8 on your tenancy. So that sort of stuff, check your config against the essential 8. Okay, well, that starts to be more viable in terms of, okay, well, now I need the AI to make my config changes, push it out. So when the bulldozer comes out from the mine, it just gets an update. It doesn't need to have some poor geologist or some bulldozer driver changing web.config, it's just not gonna work. But in this sense, the AI can then go, okay, well, in order, we've detected this type of iron ore, we've detected these certain types of materials. Well, we need to automatically update our IoT devices to be able to better hone in on that, or to not hone in on that as well. The whole low power optimization, and I mean, I've covered this a lot before, is we need to get the power consumption of AI down. I mean, there is big arguments. Well, I think everyone's seen that argument of everyone saying thank you to ChatGPT's cost them $1 million or whatever. So thank you, Mr. Computer. And I mean, OpenAI come out and said, look, that is still helpful. It is actually helping us train the model. But there will be a point where the AI don't care if you say please or thank you, and it probably, in all fairness, it probably shouldn't. I mean, if I treat the AI bad versus if I treat the AI good, should that really reflect what data it gives me? I hope not. Because what happens if I misinterpret this word or do that, or, these are more human problems than AI problems. But yet again, how do we get that cost down? How do we get the cost per, or the watt per computation down? And that's something that potentially quantum could help with. Majora 1 that's not being deployed anywhere. If you're unaware of Majora 1, that's Microsoft's quantum CPU. And that may be a solution, but it's still going to be very power intensive. So how do we actually get the amount of computations down in the AI models themselves? The storage, I mean, storage is fairly cheap these days, don't get me wrong, but storage on the cloud is still incredibly dear. And when I'm talking storage, I'm not talking like the average user consumption storage. We're not talking, 100 gig here. A lot of these places, certainly in mining and exploration, they're talking terabytes of data. A great example was the black hole discovery they did 3 or 4 years ago, where they actually used the entire Earth as a satellite, as a radar. So as the Earth spins in its orbit, they use this radar, then this radar, then this radar, then this radar to get like an Earth 4 or 5 times the size of Earth image of it. But they had so much data, and I think it was something like in thousands of terabytes of data. They flew it all together by a plane. So they put the hard drives on the plane went to the data center, and this plane over here, it's all well and good when you're paying $100 a hard drive, but if you've got 50,000 of them, not so much. So yet again, how do we handle that level of data? Because we are, and yet again, we've said this for a long time, we're moving to the era of big data. Everyone's saying, oh, big data, look at 100 terabytes or 100 gigabytes of documents. I'm like, yeah, it's a shit ton of documents. But now we're well and truly past that. I mean, how big is ChatGPT? I don't even know. I couldn't even put a size on it, to be honest. I've never actually looked, because it's going to be huge. I mean, you can, yet again, Llama, I think one of the distilled versions is only 80 gig or 14 gig or something like that. So, yet again, it's a fairly usable model. But as we look into the future, sort of 10 years, we're going to be looking at terabyte models, or hundreds of terabytes, or exabyte models. So we're going to have the storage to support that. Likewise at the edge, I mean, I want to link it back to the edge, but the edge processes are going to have to be able to throughput that sort of data as well. So just because, how often does this scanner scan? Well, does it scan every second, every millisecond, nanosecond, microsecond? Where is that line at? And yet again, it's all about balance. But if we are looking for real-time detection, what is real-time? Is it every second? I mean, yet again, in the IT world, how often do you want to back up your documents? Oh, I want to back it up real time. Like, good luck. But, what's that delay? Are you happy with a 15-minute delay or a 24-hour delay for your backups? And these are valid questions, don't get me wrong, certainly in the business aspect. But in the AI, well, 10 seconds for an aircraft, 747 at 50,000 feet, that's a big gap that you're missing. So are we talking, we scan every half a second, every nanosecond, where is these actual coming from? So not only do we have to have the throughput, but we have to have the storage. Local caching, yet again, caching is going to be a big thing, I think, as well. Now, by local, I don't necessarily mean at the very edge device, but certainly in, how long we got? Oh, yeah, off. Yeah, okay.
30-minute warning.
Yeah, cool. I mean, I could talk a lot of this. I'm trying to keep it focused. I know I'm a bit over the place, but see you later, Sheehan.
Yeah,
it's more like Microsoft kicks us out.
Yeah, correct. But the local caching, model updates, where is that AI actually living? Is it living in the USB stick? Is it living in the sensor? Is it living on the laptop? Is it living on the Azure box? Or is it living in the cloud? Probably all of them, to be honest, in 10 years' time. But what sort of local cache, what sort of local information is it going to have to help process or speed up that processing as well? And yet again, the hybrid edge versus cloud monitoring and Azure machine learning. So yet again, not yet again, but yet where we actually take our data, our information, and we learn on that. Like if we have our sensor, can it learn? Can it be more optimized? Can it be more efficient? Yet again, where is that information then stored? Is it on the sensor, or is it on the laptop, or is it in the cloud? So we're going to have to address all these different issues. Well, I wouldn't say they're issues, but they're certainly things that we will need to address in the future, especially as we get more connected. Well, I mean, where I'm going with this is also as we get more connected, the places on Earth that have no connectivity are reducing. So eventually you will be able to get full speed internet in the middle of the desert. Why? Just because we got satellites that can do it. It's just there. But yet again, would I trust mining in the middle of the desert and having all that lag? Because yet again, satellite comes with the lag. Or do I want to have local edge processing? Now, yet again, where does that edge live? But it's not up on the cloud. Where do I want all that to live? What's the acceptable timeframes for that processing, that information, all of that lovely stuff. So the challenges, as I said or briefly mentioned before, the dust and glare. Glare not so much, but glare not in the sense of humans, but glare in the sense of sensors is going to be a problem. So if I'm using a image sensor that can only see in the visible spectrum, I can fool that pretty easily. So where I come with this is, I think it was the Dutch military. They were using computer vision to look for the enemy, and someone just held up a black bit of plastic. Didn't find them. Cool. That's a problem. So not so much glare, but certainly camouflage. Now a human could pick that out, like, look, there's the enemy. But from an AI perspective, well, I'm only looking for humans. That's not a human, therefore it's not an enemy. Dust is the big one that I've sort of come across, both in terms of blinding the sensors and coding everything, but certainly the connectivity sensor. Like I was reading about the B-2 Spirit bomber the other day, and moisture got into one of their sensors, and that was the one that crashed in Hawaii. It sort of took off, flipped over, all because the sensor was too wet. Okay, cool, $2 million aircraft, write it off. $2 billion aircraft, I should say, because it was just too humid. Okay, how do we deal with that? Do we seal it off? Do we have a heater in there? Do we have air conditioning? What's the actual appropriate method or solution to fix that as well? Connectivity dropouts. I mean, the solution for that is the local caching option. So if we can't connect to Azure, fine, we can't actually have our full-blown processing, but I can put it over here until Ron can get to it later on, and we can then process it when we're actually online, get those results. But it shouldn't be able to stop my BAU. I still should be able to sort of detect, analyze, scan all that information here and now, within a reasonable degree of accuracy. So yet again, is it going to be perfect as online? No, but it shouldn't stop or interrupt my work as BAU. Heat and hardware limits. I mean, everyone's felt how hot their laptop gets on your lap. And if you're doing it in 45-degree weather, it's not going to last long. Big problem, the cooling problem. So, lightweight models, do we throttle it down? Do we throttle it up? Is it 7 o'clock in the morning? Does it, go to 80% power, but, 1 o'clock in the afternoon, we drop it down to 50% power? Do we have that thermal adaptability? False positives, as I said, with that training, that caching, that ability for the sensors to learn. Do we, loop back on itself? How does it handle that? Where is that information stored? And the flies, I mean, I'll show you some stuff there. There's no Azure service for that yet. And when I mean the flies, I mean the flies. There's thousands of them. I've got a good video up on YouTube where I was just walking in the opal fields and had the pick over my shoulders, minor. So, and I got the fly. I can't remember I got the fly net on, but I should have. But I looked at my arm and I know 3/4 of it was flies. And they're really bad. Like, they are so aggressive. And I mean, it sounds funny, but if you're out there and you're working and you're looking and you're inspecting, it is a problem that you have to deal with. So, the solution for that is don't bother with bug spray. They eat that stuff for breakfast. It's the fly nets. Oh, geez, the sparks coming off of that. I mean, you'd have to plug it into 240. Just because there is so many. I mean, when we went out of a night time, we still use the fly nets, which above ground, they're everywhere, don't get me wrong. But even I put in trenches that were 20 foot deep. And as soon as you went down the trench, there was no flies, which was good. The flies sort of stayed up above. But then you had moths and bugs. Like, come on, like, I can't win. So, you're down there looking with your white light, you got all these moths flying around. Then you go there with the black light, you got all the bugs flying around. It's like, oh, because the bug zappers are your black light, your UV. So these are real problems. I mean, yet again, and all your flies starting to get into your sensors and your bugs, we've all seen those videos where they open up the PC and there's dead bugs in there by the thousands. Very real problems. And AI at the moment is very, very sensitive. Like, it's not really built for the harsh environments. So it's interesting. What's the time? How long have we got?
20 odd.
All right, cool. So leaving all that behind for now, what's new in Azure? GPT-4o, GPT-5o. We've got some new imaging and video capabilities in there as well. It is moving towards a lot of edge processing. There is a very big drive with Azure AI to go to the edge, or to have these capabilities to be able to go to the edge. And that's all through Foundry. Foundry is going to be the unified platform for this, which is, well, I'll put an asterisk on that. Foundry is for your AI, for your GPTs, and for your for your LLMs, where machine learning is going to be for your real analytical, hardcore, deeper stuff. So that's where your sensors stuff will feed into, and then you can pull in to Foundry and vice versa. So, for example, with OpenAI, Opal AI, at the moment, it's all through customvision.ai, which is ai.azure.com, but it is transitioning to ml.azure.com, which is the machine learning workspace. So you've got Azure AI Foundry, and then you've got machine learning workspace. Bad name for it, but I'm hoping it will come together. And the IoT integration for the models is in preview. It's all sort of pulling through, or pretending to pull through at the moment. So we can start to get a lot of these sensors pulling directly into the models, which is a great thing. So what's next for Edge AI? More smaller models, Edge TPUs, GPUs, CUDA, all these different things that are coming out. Talking to a mate in Queensland today about where we are with sort of the chips and CPUs and GPUs and PUs, whatever they come out in their flavour. We still haven't found the optimal one for the optimal solution. We're still very much on the CUDA or CUDA infrastructure for it all. I mean, the NVIDIA stuff is awesome, but it's also incredibly expensive and it's incredibly big. I mean, we're talking, that's one of the CPU there. When you get a motherboard now, consumer grade with 8 of them on there, but when they're 30 grand or 50 grand each, it's still way out of play. And that gives you an idea of when Grok first started, Elon bought 16,000 of them. 50 grand a pop, you do the math. I mean, cool. I mean, at the time we were also in the 60s and 70s, we only had like 8-bit CPUs with 100 transistors in it. So eventually over time, hopefully with Moore's Law, we bring it right down. The Foundry, Microsoft Foundry's trajectory for managed endpoint, I mean, we've sort of played with this. If you've gone through like, was it the Hub, Azure Hub, where you could actually have all this information feed on Event Hub, sorry, the Event Hub service. That's kind of like what we're seeing, where we've got all these different edges and they're just feeding into this hub that can then process into the LLM and stuff like that. The NUCs and similar devices, NUCs yet again are sort of this PC you sort of stick somewhere. Are they powerful? Depends what you define by powerful, but are they more powerful than a CPU? Yes. Are they more powerful than a GPU? Yes. Are they more powerful than your NVIDIA? But time will bring that down, which then pushes it into your mobile, into your laptop, into your tablets. That's where the explosion of AI is really going to happen, because all of a sudden we won't need to have this one big, massive monolith AI that does everything. We're going to see really specializations. I did mention this years ago on LinkedIn that we'd see a fracturing of AI, and we've seen, ChatGPT was the first one, made it smart, but we've seen Grok and we've seen Minstrel and DeepSeek and Opal AI and Andrew AI. There's everything AI, don't get me wrong, and it's really fractured it. Which, I mean, yeah, again, it has its benefits and its drawbacks, because now you could say, well, one of the drawbacks is now everyone's got their AI, but one of the benefits of that is, well, it's also specialization. So do you want the general or do you want the specific? General may be fine for 90% of the stuff, but I mean, how many people are going to be out there using a oil detection AI or a gold detection AI? That'd be cool. I mean, don't get me wrong, go out to detect gold. But in terms of the geologists, that, well, okay, I want to look for just the gold versus the gold and silver and platinum. Okay, fine. That's where you really start to use specialization, and those specialization AIs don't necessarily have to be the big massive models. They can be the smaller, all-flying compact models that are really focused on those abilities. Broader use cases, I mean, yeah, real-time open classification or ore classification or ore recovery. I want to talk to Gina. So I can set up a camera on a tailings pond. Tailings like waste rock. So if I find any good ore in that, I want 10% of it. Crack AI is always funny to mention, and it's not what people think, but it's the finding the cracks in the pavements in the roads. Now, I don't know if anyone else has seen it, but certainly in my area, there is a van that drives around with, it's got about 30 cameras in it, and it looks literally on the road. But if you have an AI or essentially what every council car becomes is an edge device. So I don't need a specialized camera unit. Literally, I just put a camera on every council car, and every time it goes out, it maps which roads it goes to and which ones do and don't have cracks in it, all this sort of stuff. And then expand that further: swimming pools, grain silos, roofing, building. It's crack AI. But also agriculture, livestock, and crop health detection. I mean, I was playing with this to a degree, but it's more in horticulture, is identify the disease on the grapevine. So, okay, cool. How many sheep do I have? All right, cool. How many sheep do I have today versus yesterday versus tomorrow? And then yet again, have those analytics play off that. Well, I've got this amount of land with this amount of grass because I've sent up the drone to actually inspect that sort of stuff. I've got all that information because I've got an AI on the drone. And we can now start to look at how density is working of our livestock as well. Defense, I mean, you think of Terminators and all that sort of stuff. That's all of that. But surveillance and anomaly detection, yet again, let's just hope it takes more than a garbage bag to fool it. But you can have all of that come in through in the public sector, environmental safety compliance. Do we have actually asbestos in this building? Don't lick it. Maybe use the AI to detect it. And just on that note, as a little plug that aside for, there is a great YouTube channel called Can I Lick It? And it's about all the different elements. And he goes through and he's got the whole Can I Lick It element chart. And that is really cool. But I mean, in terms of the health and safety aspect, I mean, AI will play a massive role in that. Maybe not as big as the medical field or the chemical field. I mean, think of it in terms of, we could use AI on x-rays, on blood work. That's great. That's fine. But what about some of the new compounds that we do need? So as a practical use case that did actually happen, Microsoft wanted to have submersible cooling in their data centers. They got the AI to design a compound that actually could do it, and it was 20% more efficient. So we can actually have the whole chemist AI developing all these different compounds and chemicals that we've never even thought of. Likewise with I was going to say the human genome, but it's not, but it's way molecules twist, or I forget what it is now off the top of my head, but how the proteins twist. We couldn't really solve that until the last couple of years without AI's help. So these are some of the problems that are just going to be blown away by AI as well. Custom Vision, as I said, is moving to Azure AI Foundry. We've got 3 years essentially to move our projects off of the Custom Vision into Foundry machine learning. Now, machine learning does support a whole bunch of stuff, don't get me wrong, and we'll dive into it at the moment, next slides. But definitely, if you are using Custom Vision, computer vision, start putting it on the roadmap to migrate. It will be a little bit of a turbulent migration at the moment because the way that they're actually using like your tags, your classifications, your bounding boxes, that has changed from one format to the COCO format. So that is going to need some translation as well. Full details of the link that no one's going to go to, but Google it and look for Custom Vision migration path. As I said, there's the 3 options as well. So there's the AutoML, which is the preferred solution, I would say, and that's moving it over to the machine learning workspaces, getting the machine learning going, doing it. That's generally what people will probably do. The generative AI solutions in Azure Foundry, most people probably won't do that, but the content understanding is going to be very interesting, and I've got that in Opal AI already, where it actually takes the image and then describes that image based on what content it sees. But to dive into those, the AutoML is essentially the classic. As I said, most people will be using that as their migration path to go into it. So I won't spend too much time on that. But the generative AI solutions, they're a bit more flexible with their approach in creating solutions for customized vision capabilities. So this is where we can actually use the custom vision or the classic as well as the Gen AI. So combining those 2 together. And then the content understanding, which is like the super cool thing. This is where it is LLM, it is machine learning, but it's all sort of rolled into one to come as content understanding. So that's the new catchphrase, content understanding. And this is, yet again, it's all through Azure AI. This will be through Azure AI. But very much watch this space because I can't go too deep into it. But this is where, we will see that combination of the LLMs, the GPTs, understanding what information it's actually seeing versus, what information it's reading. So we're looking at that. And if you've been following Jensen, how or the CEO of NVIDIA, he wants to have models trained on video rather than images. Intent. Its images will give things like depth, proportion, context, physics, where my image of a dog just doesn't give me any of that, but video will give me those sort of contexts to be aware of. Q&A, that's it. So covered a whole bunch of stuff. Special thanks to everyone, my family putting up with all the flies. And big thanks to Tamara, my wife. She did a whole bunch of tagging for me. So she's actually the tagger for Opal AI.
Literally 3,000 files.
She's probably done a good 2,000. Yeah, at least. Although this weekend I am putting in 13,000 images. Well, now that I've built it up, it can use itself. So I've got, which I mean it's a big thing, because when does the AI get to a level of where you can use it to improve itself? And I know like ChatGPT, Copilot, not so much Copilot, but they do sort of dog food. They do, regenerate the information that was put in and output. Certainly ChatGPT does. Where does it get to that level where you can start to use it to improve itself? And that's going to be a big thing in the future. Is, like I said with Opal AI, I've got it to a level now where, okay, here's 13,000 images. I only want you to ingest things that have an 80% confidence. It's like, okay, well, we all seen the pug. It was pretty confident that was Opal. So where is that level at? Mate James Mill, who's helped me tremendously over the years and been a great friend with it all. Dan Measley, who will be on Opal Hunters if he's not on TV already. He was the one who was the excavator. He did the hole for me, did all of that, and I stole a whole bunch of his images and photos as well, because he is the actual opal miner, a real opal miner. And Justin McCarb from McCarb Jewelers down here in Adelaide. I got a special viewing of all their opal jewelry, and he let me take a whole bunch of photos before the store opened. So I got a big shout out to him. And thank you everyone for attending. And big thank you for Coober Pedy who put up with me, because I am seen as the AI guy in Coober Pedy and Black Magic and it's not going to work and all this sort of stuff, because we've been mining it forever with picks and shovels. It's like, yeah, cool. But industries change. It's going to change. I mean, the big thing with opal mining and why it's not a big thing like, say, gold or iron or something like that is the predictability of opal. So you can send out your geologists, go map out this big iron ore deposit that's 10 kilometres by 5 kilometres by 3 kilometres, cool. It's 7 kilometres down, cool. We'll dig it up. Can't do that with opal. There's no way to detect it from the surface. So they've tried sound, they've tried X-ray, they've tried spectra, they've had some success with gamma, but you've got to have the hole already. So it's like, well, where is it? Oh, well, let's just dig, so there's no solid way of defining it. They've had a little bit of success with conductivity, but yet again, what are we actually detecting? Are we detecting different layers of different conductivity of the rocks, or are we actually detecting opal deposits? And until someone, I think it was the university of it, one of the Italian universities was out there about 5 years ago doing that sort of stuff, and they never eventuated because it's just not reliable. There's no reliable way to find it. So you hear all these opal miners saying, "Oh yeah, it's out there." Yeah, cool. And that's when I started to get into it. I'm like, "So where do I drill?" And they're like, "Throw a rock. Wherever the rock lands, that's where you drill." Because I mean, until you put your first hole, you don't know what's actually down there. How deep because there's about 3 or 4 different levels of opal. Or potential opals. So until you sort of put your first hole and you don't know where that level is, you can't detect it on a sort of sonar scans or the conductivity stuff or anything from using thorium or phosphates or anything like that. So it is very much a big one. So yes, visit Coober Pedy. It's a great place. It's a hot place.
It's like Hollywood.
Sorry?
It's like Hollywood.
It is. I mean, and that's not AI generated. That is a real sign. So that is very much what Coober Pedy looks like. That's in the morning, I think. Best time to be out because the sun hasn't hit me yet.
Yeah.
So literally, I get out of the opal fields at just before sunrise. We knock off at 1 o'clock. It's just by 1 o'clock. It's way too hot. It's just too dusty. The explosives at the door. Yet again, real. That's real. Because I don't want them brought into the movie theatre or the very last outdoor drive-in.
Yeah.
Thank you very much for coming along, giving up your time this afternoon.
It's a janky slide.
Talk on all of it.
What happened to my face?
Next one. There we go. Sorry. Yeah, there we go.
Solar generation going on in Coober Pedy?
Sorry?
Solar generation like the... No?
Nah. Solar's only about 20% efficient. So everyone's got solar, don't get me wrong. But it's the dust. You've got to keep them clean. And Coober Pedy is a very dusty place. Now, the reason why it's dusty is A, it is desert. I mean, that's the obvious one. But 100 years of digging up shit has put dust everywhere. I mean, in the car, literally in the car park, there's still dust in there from 12 months ago when I was last there. It just covers everything. So having the solar, I mean, solar hot water is a big one up there because they just have black pipes on the roof. And that gets pretty hot. But then, I mean, gas is also big up there, but gas in terms of everyone's got a gas bottle, like the big house gas bottles. Surprisingly enough, Coober Pedy is not connected to the SA grid. It's got its own grid. Yeah. Council owns the power plant. Well, they used to. And then they got in trouble and they had to give it to somebody. Likewise with water, the council owns water production up there as well. But I had thought of, I'll have to send you a link because I've actually got a link about this, is an Azure region, the Opal region. So when Microsoft was pumping out like different data centers, I'm like, hey, you did an open air data center in the Arizona desert. How about we have Opal Palace? Actually have an Azure data center in Coober Pedy, which would be awesome. Especially there's like Opal in the actual halls. But yeah, there's just not enough resource in terms of, I mean, yes, I know everyone says solar power, but it's not.
It's nuclear power.
Well, I mean, it's not such a silly idea in my opinion. A small reactor isn't that big a deal, but obviously if it blows up, it is. But I mean, yet again, we're sort of fifth, sixth generation of nuclear reactors as well. So you could go something like a thorium salt breeder reactor, but yeah, trying to get that. Australia's had that debate for the last 50 years. And just on that note, we already have a nuclear reactor. It's called Lucas Heights. Lucas Heights is a nuclear reactor. But that's not an SA, that's New South Wales. But yeah, I mean, it would make sense, certainly. I mean, they've talked about even hydrothermal up there. So that's where you pump the water down in the ground, it superheats it, essentially just drives steam turbines. But no one's ever come through. It's all never moved past proof of concept. It's a bummer, but still plenty of opal. If anyone says there's no opal out there, oh yes there is. There's plenty of opal. So cool. Thank you, everybody. I don't know if there's any more slides, Andrew. Camera back.
I think that's it. So again, thanks for everyone for tuning in. It's online. I can't see the list of people, but mostly dropped off by now. But yeah, we'll catch you in a couple of weeks.
Sid brings up.